The lifespan of a red blood cell is about 120 days, which is around 4 months. So they're kind of like because they undergo so much stress, particularly when they're squeezing through the tiny capillaries, which are sometimes the diameter of a capillary is a little bit smaller than the diameter of a red blood cell. So they literally have to fold, to get through them. And they're bouncing against the walls of blood vessels. So they undergo a lot of wear and tear. So they last about 4 months. And they are replaced. There's a process of recycling them that includes the spleen and the liver. We are going to kind of skip that. I'm not going to go over a lot of it, but I do want you to see the products of the breakdown of like when a red blood cell is recycled, because it has to do with some of the medical conditions that can occur when things go wrong. All right, so the heme portion of a red blood cell, the iron is removed and recycled, and the heme is converted to a chemical called biliverdin, which is converted to bilirubin, and that happens in the spleen. So the bilirubin is then transported to the liver and excreted in bile. So that bilirubin in the large intestine can be broken down into urobilins and stercobilins. So these are just breakdown products of the heme molecule. Jaundice is a condition that causes yellowish skin and eyes. Sometimes babies will have jaundice when they're born, and they can correct that pretty easily with well, my son had jaundice, and they gave him a Billy blanket to take home. So it's just gives him extra ultraviolet light. You just wrap it around him, and he's exposed to that UV light, and then their skin returns to its normal color. But what it comes from is excessive levels of bilirubin in the blood. And the bilirubin levels also rise in your tissues. This can come due to blocked bile ducts, and that can happen with gallstones. It can happen when the liver fails to absorb or excrete bilirubin. And it can happen in a condition called hemolytic anemia, which involves excess red blood cell breakdown. So just different conditions. It doesn't mention here that one of the problems that happens in the liver can be from fatty liver, or it can be from hepatitis or like alcohol or substance abuse. So those kinds of things can lead to jaundice as well. But what it actually is just high levels of bilirubin, and that has a yellow color to it, so it will cause a yellowish tint in the eyes and the skin. Now, as far as iron reserves, men have about 3.5 grams of iron. Iron in its ion as iron ion. It's hard to say, but iron in its ionic form, not metallic ion. And women have 2.4 grams of iron. And that is the reason that women often require dietary supplements of iron. And if their iron levels are inadequate, iron deficiency anemia may appear. Now, men can have iron deficiency anemia. It's just a lot more common in women. And the reason, of course, is because low iron means that you don't have enough iron. The actual substance that oxygen binds to on the hemoglobin is the iron ion that is attached to the heme molecule. So if there's not iron, then oxygen can't be transported efficiently in the blood. Now, formation of red blood cells is called erythropoiesis. It occurs in the red bone marrow, and what's required for healthy formation of red blood cells, proper formation, is amino acids, iron, and vitamins, and particularly vitamin B12. And intrinsic factor is required for you to absorb vitamin B12. So you really need all those things: amino acids, iron, vitamin B12, intrinsic factor, and a deficiency in any of these things, or a deficiency in red blood cells, is pernicious anemia. Deficiency in vitamin B12 causes pernicious anemia. Okay. Now this is what I told you really don't have to know. Just know that the red blood cell formation is called erythropoiesis, and it occurs in the red bone marrow. Now, erythropoiesis is regulated by the body, of course. We don't want to have too many red blood cells being produced, because that makes the blood too thick. It's going to put stress on the heart. But we want to have enough so that we have we have enough oxygen getting to our tissues. So erythropoiesis is stimulated by low tissue oxygen. We call that hypoxia. Hypoxia in the kidneys triggers the release of EPO, or erythropoietin. This is a hormone that's actually released by the kidney that stimulates erythropoiesis, or red blood cell formation. This happens when you're anemic. It happens when blood flow to the kidney decreases. It happens when the oxygen content of the air in the lungs declines, so you're actually breathing in less oxygen. So maybe you're up at a higher, maybe you're climbing a mountain, maybe you decided to climb Everest. Or it also can occur when you have damage to your respiratory surfaces, so you're not able to get enough oxygen into your blood. All right, now we have 2 checkpoint questions. In what way would a disease that causes liver damage affect the level of bilirubin in the blood? And in that case, the liver may not be, the levels of bilirubin may build up in the blood, and you may end up with jaundice. And then we have checkpoint question 9. Keith develops a blockage in his renal arteries. And this is the arteries that supply the kidneys. That restricts blood flow to his kidneys. What effect will this have on his hematocrit? So if you said that you thought it would increase the hematocrit, you would be correct. So restricting blood flow to the kidneys, or decreased blood flow to the kidneys, is going to stimulate the kidneys to produce EPO, and that's going to stimulate erythropoiesis, or red blood cell formation. So it would increase the hematocrit. You'd have more red blood cells in your blood. And remember, that's what the hematocrit measures, is the percentage of red blood cells compared to the rest of the components of the blood. All right, now we're going to talk about blood types and the ABO blood types and the RH system. So blood type is determined based on an antigen-antibody response. And with us taking this class in the summer, one of the areas that we're not covering is the lymphatic system and immunity. So during this portion where we talk about white blood cells and where we talk about antigens and antibodies, that kind of thing, I'll try to get a little bit of immunity, in as well. So an antigen is a substance that can trigger an immune response. It may not be like, viruses cause disease and bacteria cause disease. So it may not be the entire virus. It may just be like a portion of the virus that your immune system reacts to. But it causes your immune system to start fighting, and trying to destroy cells that contain that virus. Or trying to kill those bacterial cells. So antigens it's really any chemical that triggers an immune response. It can even be something like in pollen that causes your allergies, But anyway, antigen is what triggers your immune system to fight or attack it. Surface antigens on the plasma membranes of your body's cells are considered normal. We call them self, not foreign, self. make sure you can understand what I'm saying. Self. So they're called self-antigens when they're on the plasma membranes of your body cells. But they're foreign antigens when they're on, when they come from a foreign source, not your body cells. So self-antigens won't trigger an immune response because that's part of your immune system. That's part of how it functions. Is it basically trains your cells of your immune system to recognize self-antigens and not attack them. So the presence or absence of specific antigens on the plasma membrane of red blood cells is what determines your blood type. So if you are type A, you have A antigens on the surface of your red blood cell. If you're type AB, you have both A and B antigens. The antigen's important for most people for determining blood type, because there's always exceptions, but the majority of people have three major antigens, and they are A, B, and RH, and sometimes RH is called D. So the RH is what makes you positive or negative. So if you are type A, your blood has A antigens. If you're B, your red blood cells have B antigens. If you're AB, your red blood cells have both A and B antigens. And if you're type O, the O standing for 0, your blood has neither A nor B antigens. If you are A positive, or any of these blood types, AB, or O positive, then that's because you have the RH antigen. But if you're negative, then you don't have the RH antigen on your red blood cells. So you have blood types like O negative or AB positive. Okay, so in the plasma, your blood is going to have antibodies, which we also call agglutinins and antibodies. We also call them immunoglobulins. But you're going to have antibodies that will attack antigens that are foreign. So if you're type A, you'll have B, they're called anti-B antibodies in your blood plasma because B would be foreign to you. So antibodies, also called agglutinins, are found in your plasma, and they will not attack the surface antigens, which we call agglutinogens. Agglutinogens are antigens, and agglutinins are antibodies. The shorter word is for antibodies, and the longer word is for antigens. But they won't attack your self-antigens. So if you're type A, you're not going to have anti-A antibodies in your plasma. So you're not going to have anything that's going to attack your own your own antigens. Okay, so antibodies will attack foreign antigens on red blood cells of different blood types. Type A blood contains anti-B antibodies, which are going to attack B antigens. Type B blood contains anti-A antibodies, which will attack A antigens. If you have type AB blood, you're not going to contain antibodies for either A or B because you have both of them. So you're not going to have anything to fight against those. If you're type O, you'll have both A and B antibodies. And here is an illustration that shows you up top, you're going to see the red blood cell and the type of antigen that's on the surface. And then you'll see below that the antibodies that are found in the plasma. So if you have type A blood, and this chart doesn't look at whether or not you're Rh positive or Rh negative. So if you have type A blood, you've got A surface antigens and B antibodies. If you're B blood, you have B surface antigens and A antibodies. A antibodies. If you're type AB, you have both A and B surface antigens and neither A nor B antibodies. And if you're type O, you don't have A or B surface antigens, but you have both A and B antibodies in your plasma. So what happens is if you get a blood transfusion from the wrong blood type, a cross reaction or transfusion reaction can occur. And that occurs when antibodies in the recipient, which would be you, react with their specific surface antigen on the donor's red blood cells because you got the wrong incompatible blood type transfused. This is going to cause agglutination or clumping of the red blood cells, which can, it can lead to death, but it can cause tissue damage and just a lot of damage to your organ systems. So it's really important to find out if your blood type is compatible with the donor blood type. And we'll talk about that in the next